Well, hello again, geometry. So let's actually look at some examples with reflections. Now, the first examples we're going to investigate and take a look at are horizontal reflections. And so horizontal reflections by themselves are not incredibly difficult. The layer here that makes it more difficult is when we start adding in the description with some academic mathematical vernacular. So first, let me go ahead and sketch an example here so we can all get on the same page. So here's my wonderfully straight vertical line. Boom. Wonderfully straight horizontal line. Boom. Now, ladies and gentlemen, a horizontal reflection means it's reflecting from left to right. So it's going left and right. Now, the hard part here is when we talk about the line of reflection. And so we might be reflecting from left to right, but every reflection that happens over a line. And so when we talk about that reflection more academically, a reflection is essentially moving corresponding points equidistant over the line of reflection on a perpendicular line. Almost forgot to write the word moving there. And so a horizontal reflection here, in order for that to really map out and make sense, let's go ahead and draw in a shape. Don't have any particular shape that's my favorite, but this looks like a pretty fun shape to draw. It's like an arrow, but only half of it. I actually want that. I do not want sticky keys. Thank you, though, for asking. There we go. So I got like half an arrow there, right? So stick with me, you guys. We're going to reflect this shape over a vertical line in order for it to flip from left to right. So we already know that the shape's roughly going to look like this over on the other side. Like, that's not going to be too much of a surprise. It's going to look like that. But in order to get that, we are going to need to take advantage of this vertical line, the line of reflection that I'm referring to, and understanding what that looks like. So I'm going to go ahead and pick a nice gray color here. And let's talk through it. First off, a horizontal reflection means that our vertical line is here in the middle. So the green line there is our vertical line. That vertical line is the y-axis. Ladies and gentlemen, the y-axis happens. All of our different y values can happen. So we can have y equals 1 or 2 or 3 or 4 or 5. All of those y values can happen when x equals 0. The y-axis is the equation x equals 0. A horizontal reflection in this example is happening over the line x equals 0. And so when we talk about matching up points then, we're looking at finding the points that are equidistant on the other side of that line. And so we have 1 point away from the line here, which means 1 point away on the other side, we have our new one. And we're able to match that for all of the points. There's 3 away from the line, so on the other side, 3 away is our next one. And so we're able to continue counting that and laying that out. And so here, this one, for example, is over 1, 2, 3, 4, 5. So we're going to go over 5. Plot that one and plot this one. And so, ladies and gentlemen, because we were able to count all of those lines, all of those points, we can identify what our new shape is going to look at. There we go. And boom. And so there is our reflected line over a vertical. There's our reflected shape over a vertical line. Let's go ahead and look at a vertical reflection. So while this is a horizontal reflection going left and right, we're able to do the same thing with a vertical reflection, but the only thing that's going to be different is that instead of having a vertical line, we're going to have a horizontal line. Now, before I move on, I do absolutely need to clarify, in case I haven't said it clearly enough already, that this black shape here was our pre-image. That's our shape before the transformation. And then the gray shape over here is the image, the shape after the transformation. So here we go. We have a vertical we're going to have a vertical reflection, which means we're going to be doing it over a horizontal line of reflection. So first, let's get our axes. Oops, that one didn't straighten for me. Let's try that again. There we go. Got our straight line. Got our straight line. Excellent. Now I'm going to use that same shape that I talked about a second ago. I really like that shape. It's like a nice little half arrow. Boom, 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 and boom. Perfect. So, ladies and gentlemen, a vertical line means, a vertical reflection means we need a horizontal line of reflection. So here's our nice horizontal line of reflection. The horizontal line of reflection is happening at the x-axis, and the x-axis happens when y is equal to 0. The easiest way I track that and try to remember it isn't by trying to remember that the x and y are flipped or somehow paired up. Instead, I think about what the actual value is. The x-axis has all of the x values. So if I tried writing that x is equal to 0, then that doesn't make sense because I also have x equals 1 and 2 and 3 and 4 and 5. And so it's a common mistake to be thinking about the x-axis and then to write x equals 0 as your equation. That is a common mistake. And the easiest way I've found to check that is to pause and process, well, is x equals 0 the only x value I'm working with? And generally, that's enough to help me remember to put it from x to y. Because on the x-axis, the y value, the distance up and down, is always 0. We're not going up or down on the x-axis. And so it's able to track and keep track of what our equation is versus what our axis is. And so flipping this shape over the x-axis, then we're able to see the distance from our line of reflection. We're going up 1 to get to that point, so down 1 is where its corresponding point would be. And that's going to be the same thing over here on the other side. And then the same thing for the rest of our points. We're able to count the distance away. That point's going to be 4 away. we're able to count the distance away for each of those points, which is going to be how we recreate our shape. And so our image now can be drawn in. So we have our reflected shape. No thank you, sticky keys. So, ladies and gentlemen, we've reflected vertically, we've reflected horizontally, and it is just about counting how far away from the line of reflection each of our points are to then plot them on the other side. All right, so last example here. Let's go ahead and track a reflection point by point, because that's going to be another layer to this unit, is we're going to be needing to track how the reflection looks with our X and Y coordinate pairs, with the actual points themselves. So let's go ahead and use this wonderful example to illustrate that. Let's go ahead and draw in our Y-axis and our X-axis, and let's go ahead and plot in our pre-image. The pre-image is going to be, for this particular example, here, here, and then here. Boom. And so what points are we actually looking at then? Well, this point here we're going to go ahead and call A. We're going to keep it simple. We have A, B, and C for our triangle. And so, point A is at the point -1, 2. B is at -4, 1. And C is at -5, 4. So, ladies and gentlemen, like I said a second ago, if we're doing a horizontal reflection, it means we are reflecting over the y-axis, and reflecting over the y-axis means we are reflecting over the line x equals 0. And so when we do that reflection, I mentioned we're talking about perpendicular lines, which means we essentially can draw the line perpendicular and track the distance from one side to the other side. So to get to A prime, we want to go 1 to the left and 1 to the right. And that's how we're going to end up with A prime. And where is A prime now? Well, A prime is at the point +1, 2. The y value did not change. The x value, it went from positive to negative. So we're going to do the same thing for B prime and C prime. B prime here, doing that same thing, we're able to draw our line. So that's going to be 1, 2, 3, 4 away from our line of reflection, which means we want to go 1, 2, 3, 4 onto the other side. That's our perpendicular line that's able to track that distance. And so here, let me go ahead and pick a nicer color than that. Goodness gracious, here we go. So get 4 in both directions. And so we have our point B prime. B prime has the same y value of 1, but an x value of +4. And then, last but not least, we have C prime. I'm going to go ahead and use red for this one. C prime is 5 away. So go 5 in the other direction. 1, 2, 3, 4, 5 is how we're able to track where C prime ends up. And so, once again, +5, +4, and we have all 3 of our points for our image. Ladies and gentlemen, that's a reflection point by point. Looking forward to seeing you guys in the next video.